Okay, so today we're talking about periodic behavior, and we're just going to do the definition of a periodic function. So a periodic function, it's sometimes easier to visibly see than it is to explain in words, but essentially what we're looking for, if a function is periodic, you will notice that the pattern of this function repeats, and then as soon as it ends, it starts repeating again. So it's a continually repeating pattern of y values over a regular or a fixed interval of x's. Okay, so that's kind of what we say. Nicole?
Is this waves in physics?
You'll notice a little bit of crossover, but not much. Okay, so a function with repeating y values over a fixed interval of x values. Essentially, what we would be looking for visually is that there is a continually repeating pattern, and it's the same pattern over and over and over again. Yeah, so if you've taken physics, you will probably notice a couple crossover elements between like some terminology that we use and then also how we calculate certain things, but we're going to talk about how specifically trig functions with waves. Do you use trig functions in physics? No, so it's a little bit different. You do? Yeah? Okay. So yeah, you'll probably see some crossover. Okay, so if we look at the examples of these two graphs that we see below, essentially what we would be looking for to define these as periodic or not periodic is, does the pattern repeat? And as soon as that pattern is repeated again, it should be immediately after the pattern ends the first time. So visually, for question I here, does this look periodic to us? Does it look like the pattern repeats and then repeats and then repeats? Yes. So let's suppose we start here. I have one section of the pattern, and then we'll notice that immediately after that section of the pattern stops, it starts again, right? So these are two, what we call periods of this periodic function, or two cycles of this periodic function, I should say. Okay, so yes, this is periodic. Is the second one periodic? Why not, Derek? Yeah, so I would have to have, you see these mountains in between here? So although these guys are all the same, unfortunately the mountains up here, well, not unfortunately, it doesn't really matter, but the mountains in between the smaller mountains are not the same height. So I would need this, maybe this mountain right here to be continually repeated between those smaller ones. The pattern needs to be exactly the same. So this one is no, it's not periodic. Okay, so there's certain elements of this that are, they're repeating, but it's not starting the pattern and then the pattern finishes and completely starts over again. So it would almost have to look like the first part of that pattern is copied and pasted over right after it ends, which doesn't work with part two. Okay? All right, so firstly, is our function below periodic? The pattern repeats, we can see that visually, so that would be a yes. So essentially what we're looking for is a continual repeating pattern. Okay, amplitude. If so, oh, I missed our our definition of amplitude up here. Oops. Okay, so yes, it's periodic. It's asking what is the amplitude. So firstly, we need to know what is an amplitude. My physics people might know the answer to this. So does anybody know what an amplitude is? It's okay. Nicole?
Distance from like that x-axis to that top highest peak.
Right. So it's the distance from the middle of your function to the max and the middle to the min. So we say that this is a measurement of, like when we're talking about waves specifically, we say it's like the middle to the top of the crest and the middle to the bottom of the trough or whatever. But essentially, amplitude is the distance from the middle to the max and also the middle to the min. So it's half the height of your graph. And these will be equal, right? So I'm saying or middle to min because these things are the same. If it's the middle of the graph and I count the number of units to the max, and it's the middle of the graph and I count the number of units to the min, those values should be the same. So essentially it's just like if I know the entire height of the graph, I will take that and divide it by 2. So it's half the height of the graph. Or of the function, maybe we should say. Okay, there is a way that we can calculate amplitude. There's a little formula. Do you guys use this in physics? No? Okay. So you're working on it right now? Okay. So it's max minus min divided by 2. Okay. Essentially, you could count the number of units from the minimum to the max and then divide that by 2 and you'd have your amplitude. So for this one, can somebody tell me what the highest value is on our function? What is the max? Here's a maximum right here. Okay, good. And what's the very lowest point on our function? There's one right here. What's that? -1, okay. So if I want to find amplitude, if I'm not exactly sure how many units this is, I can definitely, like how many units are from -1 to 3? 4 units, so the amplitude should be 2. But if I'm not entirely sure, I will plug into our formula from above, and then we can just calculate. So it'll be 3 minus -1 all over 2, and then we'll get 4 divided by 2, which gives us 2. Okay? Amplitude, just as a little side note, amplitude should always be positive because we're talking about a measurement of height. So I definitely don't want a measurement of height or distance or anything like that to be a negative value because that doesn't make sense. So you can make yourself a little note up here if you want under your amplitude definition and just say it's always positive. Okay, so that's our amplitude for this function. It's equal to 2. So if I know amplitude is 2, I know the entire, from the minimum to the max, the entire graph is 4 units vertically. Okay, any questions on that? So far so good?
I don't understand. Why is it always positive?
Because we're talking about a measurement from like how many units it is from the middle to the max or middle to the min, which we use as like, we're just counting number of units. We're not counting about, like we're not counting like, oh, I'm going down or up, right?
Okay.
Yeah. Okay. Cycle of a periodic function and then period. So a cycle is essentially one section of your pattern before it begins repeating again. That's kind of the simplest way that I could explain it. So one section of a complete pattern before it begins repeating again. Okay, and then the period is essentially the horizontal length of the cycle. So again, we want period to be positive because we're counting the number of units that it takes for a cycle to start and then finish one single cycle. So it will be the horizontal length of one cycle. Okay, so again, these are a little bit easier to actually show you visually than they are to explain. But let's say I just start over at the very left over here. We can kind of trace along and see that our graph doesn't start repeating its pattern until this point right here. Does everybody see that? So after that point, the pattern is now repeating again. Agreed? Okay. So if I want to find the length of this cycle, I'm just going to count from the start to the finish how many units there are. So I'm counting 1, 2, 3, 4, 5, 6. 6 units. So that means that the period of this function equals 6. Okay. How many cycles do you see? How many complete sections of this pattern can we see on our graph here?
2.
We can see only 2. We see actually 2 in a bit, but complete cycles, I can only see 2. Here's one in red, and here's another one in blue. So we see 2 cycles. And this also asks us to find the amplitude. So in order to find the amplitude, we're going to identify the max, which is 3, and the minimum, which is -2. And then I'm just going to calculate here. So I'll do max minus min, all divided by 2, and that gives me an amplitude of 5/2. We'll just leave it as an exact value. Okay, one little side note here, the period does not always necessarily need to be calculated from like along the x-axis. I could have also calculated it. It can be from a max to a max, measured that way. It can be measured from a min to a min. So if I want to know period, I could even just see like how many units are between those 2 peaks there. So it's like 1, 2, 3, 4, 5, 6. And we should get the same thing no matter how we measure it, as long as we're taking one complete snip of that whole pattern, right? I can also measure it from min to a min if I want. But those period values should be the same. Is there a question over here?
Oh yeah, I was going to ask if we always do it in exact values.
Yeah, we'll leave an exact value where we can. Okay. All right, so we can use this idea that graphs kind of continually repeat to predict values that are not necessarily visible on our graph. So in this question, same graph as before, so we know that the period of this function was 6 from what we found in our last example. So we're just going to keep that in mind as we do this question. What I'm looking for here is I'm looking to see where the y values are equal to 2. So for what x values is this function equal to a y value of 2? Can somebody give me one x value that has a y value of 2 on this graph? 0. Yep, 1's right here. Okay, so f at 0 is equal to 2. Does anyone see anywhere else that would have an x value that has a y value that's equal to 2? Alex? 6. F at 6 is equal to 2. Anything else that you can see? -6 is another one. Okay, this one asks us to figure out 4 though. So I have to imagine that this pattern is now continuing off of what I can visibly see in this example here. So what can I visibly see? Well, I know that every single 6 units, so if we count 1, 2, 3, 4, 5, 6. That's a period, right? So it means that that point is going to be repeated every 6 units. So if I imagine 6 units from this value right here, what would be the next time that I hit a y value of 2? 12, yeah, because the period is 6. So every 6 units apart, we will hit that y value of 2. Could somebody give me another one? Negative 12 would work as well. That's also equal to 2. 18 has a y value of 2 as well, and so on. Okay, so it repeats forever. Any questions for this one? Does that make sense? No? No, no questions. Okay. I thought you were saying no, it doesn't make sense. Okay, so we can find it the one way where we find the x value that has a certain y value. We could also do it the opposite way. So we can predict values that are off of our graph for what we can visually see with values that we know are on our graph. So again, same period for this one. The period is 6. Okay, again, if you're not sure, measure from a max to a max and then see what that gives you. So if I'm predicting with the x values what the y values are going to be equal to, I'm going to use that period and I'm going to say, okay, f at 8, that's actually off my graph. I can't really see that right now, but I know 6 units before x is 8 is going to have the same y value. So what's 6 units before 8? Yeah, so if I subtract 6 units, I know that I'm going to have the same y value there, because again, that's the period of the function. So f at 2 should actually be equal to f at 8. So I'm actually going to put that at the beginning here. So f at 8, so we can add or subtract any multiple of the period that we need to. Okay, so can we see f at 2 here? What's the value of f at 2? Well, here's the point right here. So what's 1? Yep. So f at 8 is equal to 1. Okay, negative 10. Do I have to add 6 to negative 10 or subtract 6 from negative 10 in order to get to something I can actually see on my graph? Bonnie? Yeah, we should probably add it because if I subtract it, I'm going to go even further into the negative direction and I can't see any of those values on my graph, right? So I think I'm going to have to add 6 to it this time. Again, we're adding 6 because that's the period. It might be different for other questions. But that tells us that f at negative 10 is actually going to be the same y value for f at negative 4. So what's f at negative 4 from what we can see on our graph? Points right here. 1 again. Okay, and then f at 14. If I subtract 6 once from 14, I'm actually getting f at 8, which we actually calculated earlier, but I could also subtract 12 from f at 14 because it's a multiple of my period. So any multiple of my period should work. So when I'm trying to do f at 14, that should be equal to 14 minus 6 and also 14 minus 12, 14 minus 18, and so on. So any multiple of 6. So I think we could just do like minus 2 times 6. So we get f at 2, because that's 14 minus 12. And we already know f at 2, just from our earlier calculations, was equal to 1. So these ones all just so happen to be exactly in the same position. Y coordinate wise, not necessarily x coordinate wise. Okay, does that make sense? Any questions? Okay, so those are periodic functions. We're going to do graphing sine and cosine, and the second part of this lesson, we're going to do this actually on Monday. So what I'm going to have you guys do for today, let me just stop the video.